Assalamu alaikum student. So our today's topic is projectile motion. A projectile motion is a form of a motion experienced by an object or a particle that is thrown near the earth's surface. Okay, when it's thrown near earth's surface and moves along a curved path under the action of gravity, so it will come down again. Okay, whenever it's thrown. So in particular, the effect of air resistance is assumed to be negligible. Okay, so we're assuming that there is air resistance which is neglected. So when an object or a projectile is projected at an angle of elevation, this is an angle of elevation, this would be theta. Okay, so this would be angle theta. And the horizontal distance that is covered by that, if it's a ball that's covered, and the vertical distance of the object. We use parametric equations. The horizontal distance and the vertical distance covered. Now both of those are depending on time. Okay, so for projectile motion, the horizontal distance is given by x equals t times v naught cos theta. And the vertical distance, this distance, the vertical distance at time, this is y and this is x. They both are depending on time. And the vertical distance is given by y equals t times v naught vo sine theta. It's the same as we had the parametric equations. This is v naught is velocity, which is added to the projectile motion. Now there is always a force of gravity which is being subtracted, which is pulling it down. So the force of gravity 1/2 g, which is the gravity, t squared, plus the height h naught. I'm going to explain you. It seems hard, but once you know the equations, the parametric equations. The parametric equations, why they are called? Because x and y, they are both depending on t. The horizontal distance depending on t and the vertical distance is also depending on t. Okay, now it's not always that a ball is thrown from the ground. It could be someone throwing, a boy is standing throwing from here. So the height of the ball where it's thrown will not always be 0. It would be sometimes 5 feet, depending on where, or maybe something is dropped from the roof. Okay. So here t is time, v naught is the initial velocity, and g is the gravitational constant, h naught is the initial height, here. When it's thrown from the ground, the initial height would be 0 because it's ground. But when something is thrown from the height, the initial height would be that. Okay. Now the gravitational constant is the acceleration of the object due to gravity. Okay. At the surface of the earth, this value is 9.8 meters per second squared, or 32 feet per second squared. So if the measurements are given in terms of meters, you will be using 9.8 for g, and if the values are given in terms of feet, you will be using 32 instead of g. Okay, so let's start with the example. Mark kicks example number 1. Mark kicks a soccer ball upward from the ground with an initial velocity of 75 feet per second at an angle of elevation 62. So this is, we have to identify what is given. This is theta. This is velocity, initial velocity, which is v naught. So initial velocity v naught is 75 feet per second. Now we are using feet, so we are going to be using g as 32. Okay, make a diagram of this situation. So for the diagram, I'm gonna do x and y. See, now it's the ball is kicked from the ground. So from here, okay, this is the ground. the ball, and it will be taking and it will be coming down. We do not know where. Okay, the angle this formed is 62 degrees. Got it? Write the parametric equations to describe the horizontal and vertical position of the ball. Now it's a horizontal and vertical, use these equations. So for horizontal, I'm going to use x equals t times initial velocity cos of theta. So t times initial velocity is 75 cos of 62 degrees. Use your these are the equations. Okay, you can change it into and find the value of cos 62, times it by 75, and you will get the equation. Well, actually these are the equations we're going to use. Okay, now for y, the vertical distance, y equals t, we do not know t, times v naught, which is 75, times sine of 62 minus 1/2 of g. Now they are saying feet per second square, right? So we are going to take 32. If it was meters per second, we would have taken 9.8. So 1/2 times 32 t squared plus h naught. H naught is the initial height. The initial height was 0 because it was kicked from the ground. So it's 0. Now simplify, we get y equals t times 75 sine 62 degrees minus 32 times 1/2 is 16 t squared plus 0. So this is what I got. I can write it as negative 16 t squared. Now you can see if I just keep arrange them, I would get negative 16 t squared. It's a parabola. T squared is a quadratic, so it will give you a negative upside down parabola. Okay, find the horizontal distance the ball has traveled at 2 seconds. So I'm going to use this equation, replacing t with 2. This means t equals 2 seconds, and I'm going to find the value of the horizontal distance. So it would be x equals t is 2, so I'm going to replace that this t by 2. I get 2 times 75 cos of 62. Plug it into your calculator, everything, and you will get as x equals, to take it to the 100th to 2 decimal places, 70.42 feet. Horizontal distance, you're going to take feet. Find the vertical position of the ball at 2 seconds. So the vertical position, I'm going to use this equation, y equals 2 times 75 sine 62 minus 16 t squared, which is 2 squared. Okay, so the final answer I get is y equals 68.44 feet. So the ball was 68.4 feet up, and it traveled 70 feet horizontally. Okay, example number 2. I'm going to do all the examples. A tennis player serves a ball at an initial velocity of 35 meters. So this is V naught per second, and the ball leaves the racket at the height of 2 meters. So the initial height here is h naught is 2 meters at an angle of elevation 45 degrees. This is theta. Make a diagram of this situation. Now in this case, this is 0, this is y. Now the ball is not served from the bottom, from the ground. It's served from 2 meters up. If this is 1, this is 2. Okay, so ball is thrown from here, right? This is 2 meters. From here it will go up, and the force of gravity will bring it down, so it will come down somewhere. Okay, so this is the situation, the graph. Now write the parametric equations to describe the horizontal and vertical position of the tennis ball at time t. The same you're going to do for horizontal, for vertical. We are going to write the equations. So x equals t times v naught. V naught is 35, right? 35 cos of 45 degrees. The angle it made is 45 degrees. Okay? And for y, this is my final horizontal distance equation I'm going to use. Y equals t times 35 v naught sine of 45 degrees minus 1/2. Now, instead of g, I'm going to use 9.8 meters because it's in given meters. So I'm going to do 9.8 t squared minus the h naught, which is 2. Sorry, plus 2. It's plus. Okay. Simplify, I get y equals t times 35 sine of 45 degrees. When I simplify, I get 4.9 t squared plus 2. This is my vertical distance equation. Find the horizontal distance. The ball has traveled at 1.5 seconds. This means I have to replace t with 1.5. Use the equation and find the value. And make sure the final value is in terms of meters. Okay? Find the vertical position of the ball at 3 seconds. Here you take t equals 3, plug it into this vertical, and you will find the value. Okay? Now let's do the other 2 examples. Actually, 3 examples. The third example is a football is kicked from the ground at a 45-degree angle of elevation with an initial velocity 60 feet per second. How long is the ball in the air? So how long is the ball in the air means here in this case, I have to understand that this is theta and initial velocity of 60. So this is v naught. When I say how long is the ball in the air means, if I use my vertical distance equation, which is horizontal is x equals t cos t times v naught cos theta, and y is t times v naught sine theta minus 1/2 g t squared plus h naught. In other words, how long is the ball in the air? If I use my vertical and I say that I have to find time, so it started here, okay, and the when a ball is kicked, it goes up and it comes back to the ground here, is it? So this is the angle. It's kicked from here, which is 45 degrees. It kicks from here and it comes down here. So actually these 2 points tells me the x-intercept when y is 0. So if I figure out the t, if I plug in y equals 0 in this case, I can find t from here. I will get 2 values of t, the time. The first should be 0 because at time equals 0, the ball was not kicked. But as the time moves on, it's in the air, and when it hits the ground, it's when y is 0 again will tell me t. Okay, so I'm going to use my equation y equals t times v naught, which is 60 sine theta, sine of 45 actually, degrees minus 16. Why am I using 16? Because it's given in feet. So if I use g as 32, 32 times half is 16. So I'm just going to simplify and I'm going to write 16t squared plus h naught is 0 because there is no initial height, it's from the ground, so I don't have to. So if I put y as 0, meaning the 2x intercept, I will get t, which will tell me that for how long my ball was in the air. So when I plug this equals to 0, it gives me t times 60 sine of 45 degrees minus 16t squared. So I'm gonna do, can you see the quadratic equation here? So I have to find the value of t. So to find the value of t, I'm gonna do, either you can simplify this and write the value, or I'm gonna use the same thing so that I can round up in the end. Minus b plus minus, I'm gonna use the quadratic formula, minus b. So this is b and this is a, minus b. 60b is 60 sine 45 minus b plus minus b squared 45 b squared minus 4, a is 16 and c is 0. Okay, so this terms become 0 because 4 times 16 and 0 gives you a 0. So I get t equals negative 60 sine of 45 plus minus 60 sine 45 whole squared. Okay, plug it into your calculator and you will get the two values. T equals 0 because when you add, and the other value would be 2.65. So t equals 0 will be this. At this point, when the time was 0, the ball was on the ground, was not kicked yet. Then for t equals 2.65, after this the ball hit the ground. So the ball stayed in the air for 2.65 seconds. Find the horizontal distance the ball covered. So as we know that the time is either this 0, so it was not kicked. So if I figure out that the ball was in the air for 2.65 seconds, meaning after this is, if I plug in this in the horizontal distance, it is x equals to t times v naught, which is 60 cos of 45. I know the time covered by the ball is 2.65. I'm going to replace x equals to 2.65 times cos of 45 degrees. Plug it into your calculator and I will get x equals 112.43 feet. Okay, example number 4. I'm doing all the examples. A baseball player in the outfield throws a ball towards home plate. The ball leaves his hand at a height of 6.5 feet and an initial velocity of this per second. So this is the height h naught and this is the initial velocity. Okay, that's what we are given. The ball is caught by the player at home plate for after 1.8 seconds. This is what t. If the ball traveled a horizontal distance of this, find the angle of elevation. So now they told us the distance traveled, which means they told us this x. So we are going to use this equation, x equals t v naught cos of theta. We know that this distance traveled is 191. Time is 1.8 seconds. Okay, v naught is 110 times cos of theta. We have to find this theta. So I'm going to multiply this. I get 191 equals, when I multiply this, I get 198 cos of theta. I have to find theta. I'm going to divide both sides by 198. I get cos theta equals to 191 divided by 198. To find theta, I'm going to take cos inverse of this. So theta equals cos inverse of 191 over 198. My final answer would be theta equals 15.28 degrees when I plug it into the calculator. So the angle you used to do was, now what was the height of the ball when it was caught by the player? So we are going to use this equation. Now we know t, because t was 1.8. We know theta. Theta is 15.28 degrees. Half g, we know we are going to use, because it's feet, we are going to use 32. And h naught is the height, which is 6.5. And we can find out y equals, I'm going to use t times 110 sine theta minus 32 times half is 16 t squared plus 6.5. I'm going to replace t with 1.8 and find the value of y. Okay, that would be in feet. Now the last example, example number 5. A projectile is fired from the top of a 24-meter tall building. So this is the initial height. Angular elevation is 28 with an initial speed of 55. What is the maximum vertical height reached by the projectile? Okay, now I know it's going to be a parabola, right? The projectile is fired from a 24, this is 24, it's fired from here at an elevation of 28 degrees and it comes down somewhere here. Okay, so this is 28 degrees and this is 24 meters. This is the height. Actually, they're asking you what is the maximum vertical height. They're asking you this vertical height. If you remember quadratic equations, this point is the vertex. Okay, so we are going to use the equation, because they're asking find the vertical height, we are going to use equation y equals t. So I'm going to use this equation, y equals t, which is, did they give us t? No, they didn't give us t. That's what is the maximum vertical height reached by the projectile. Okay, yeah, we're going to use this. Y equals t times 55 v naught sine of 28 degrees minus, because it's in meters, I'm going to use 9.8 as g, and 9.8 times half is 4.9 t squared plus h naught is 24 meters, the initial height. So I'm going to write 24. Okay, now by using this equation, I know that this is the vertex. Okay, when I'm finding the vertical distance, it's a parabola, right? So if it's just this equation, then this is y and it's depending on t, so this would be t, right? So this tells me the vertex, and the vertex would be t and y. To find the vertex, we know that vertex, the x coordinate of the vertex is minus b over 2a, the x coordinate. So t is equal to find the vertex, the x coordinate of the vertex, we'll figure it out. T from here. Now once we get this t, we'll plug it into this equation to find y. So to find t, I know that it is minus b over 2a. Now if I arrange this equation, this is a, because it's with the t squared, this is b, and this is c, the constant. Minus b over 2a means minus 55 sine 28 over 2 times negative 4.9. Okay, so when I plug this into the calculator, I get 2.63. Now I know what my time is. Once I know the time, I'm going to plug it into this equation and I will find the height of the maximum height of the vertex. Okay, so recall from the vertex, x coordinate of the vertex, meaning this. So once I plug this t back into my original equation, I get y equals 2.63 times 55 sine of 28 minus 4.9, 2.63 to the power square plus 24. This will give me the height 58.02. So always remember, to find the maximum height, you are going to use this vertical distance equation. Find the t using the vertex minus b over 2a, and then plug it back to get this height y. Okay, find the horizontal distance traveled by the projectile at the time it reached its maximum height. So when it at the time, so we are going to use this time. What was the time? This time when it reached. So what was the horizontal distance? Okay, so I know now this. So I'm going to use x equals 2.63 times 55 cos of 28. This is x equals t times v naught cos of theta. Find the, use your calculator, to 127.72 meters. Okay, so the horizontal distance, we're using this equation. The time is this when it reached the maximum height. This is the horizontal distance. If the projectile is fired towards a building that is 3 meters away, will the projectile hit the building? If not, how far from the building it will? So that is 300 meters away. Now again, when the projectile hits the ground, the height becomes what? 0. So they want to know that there is a building here which is 3 meters away from the ground, this is thrown towards the building which is 3 meters away. So the building is somewhat 300 meters away. Now if the projectile is thrown in such a way, is fired in such a way, they are asking, is it gonna be how far is this projectile? Is it far, or it will land by the building, or it's gonna be far? So this we know that when it reaches here, my y becomes what? 0. So when I use this equation, the vertical distance equation, I know y equals t times 55 sine of 28 degrees minus 4.9. Why I'm using 4.9? Because 9.8 meters times 1/2 gives me 4.9, plus h naught was 24. So now my y at this point, my vertical distance become 0. So t 55 sine 28 degrees minus 4.9 t squared plus 24. Plug it all into, now here we have to use the quadratic equation again using the quadratic formula. So you do minus b plus minus, because we have to find the time first. Once we get the time, that's how we will find the horizontal distance. Okay, so first we find out using the vertical distance, we will find time, and once we get the time, we will use the horizontal distance equation. Okay, so now I'm using the quadratic formula. T equals minus b, which is minus 55 sine 28 theta degrees, plus minus b squared, which is 55 sine 28 degrees minus 4, a is minus 4.9 times 24, c, over 2a, which is 2 times negative 4.9. So I get t equals, two values of t, I will get negative 0.81 and 6.08. As I know, negative cannot be. So this is the time when the ball hits the ground. Y equals 0 means ball hits the ground at 6.08 seconds. Now I'm going to use 6.08 seconds to find what was this horizontal distance covered. Then I will figure out how far it is from the building. So x equals 6.08 because x equals t times v naught cos theta. 6.02 v naught initial velocity is 55 cos of 28. I get x equals 29.26 meters. And my building is 300 meters away. So how far it hits the building? You subtract 295.26 from 300, so it hits the building. It hits the ground 4.74 meters from the building. This is your final answer. So we figured out y, how to find y. We figured out t by putting y equals 0 because it hits the ground. The vertical distance becomes 0. Once we get t, we plug it into this horizontal distance equation to find how far the ball reached. So this distance is 295.26 and this distance is 300. How far is it from the building is 4.74 meters. I hope you understand the concept. Assalamu alaikum.